Hello, my name is Donald Lifite, and I work for FEMA Region 6 in my role as a civil engineer and building science lead. Welcome to the overview of the second edition of FEMA P-804, or Wind Retrofit Guide for Residential Buildings in Hurricane-Prone Regions. This edition of FEMA P-804 was published in April of 2023 using FEMA disaster funds from the state of Louisiana following Hurricane Ida and is available online in FEMA's Building Science Resource Library for download. Every year, houses along the coast are subject to high winds that cause extensive damage and threaten the safety and security of coastal residents. Much of this wind-related damage can be reduced by improving the performance of the existing buildings through retrofits that strengthen the residential building's envelope and load path. FEMA P-804 presents mitigation measures that must be implemented for a house to provide a defined level of protection. Implementing the mitigation packages in this guide on existing vulnerable houses within hurricane-prone regions of the United States and its territories will result in their improved performance in high wind events. FEMA funds can be utilized to implement these mitigation packages, and FEMA P-804 outlines minimum technical and performance-based grant requirements related to residential wind retrofits. Today, you will hear from multiple presenters as we provide you with an overview of this newly updated FEMA publication. This presentation will provide a high-level update summary, as well as more detailed chapter-by-chapter overview. The end of the presentation will provide you with where to go for more information. Let's get started with the high-level overview of FEMA P-804 and some history of its development and recent update. Hurricane Katrina damaged or destroyed 234,230 single-family homes, including manufactured homes in Mississippi alone. Following this devastation, the Mississippi Emergency Management Agency's Mitigation Section, in coordination with the Mississippi Department of Finance and Administration, applied for a Hazard Mitigation Grant Program grant under the presidentially declared disaster to fund wind retrofit projects for homeowners affected by Hurricane Katrina directly, or to enhance resilience for future events. The first edition of FEMA P-804 was written to provide the technical guidance needed to facilitate the development of FEMA-funded retrofit projects for residential buildings. This first edition of FEMA P-804, developed in 2010, provided engineering-based prescriptive construction solutions for wind retrofits, implementation guidance, and wind damage function data to support user-identified damage curves for performing the Related Benefit Cost Analysis, or BCA. A BCA is required when seeking FEMA grant funds. Hundreds of successful residential wind retrofits were funded by FEMA and implemented through the Mississippi Emergency Management Agency's program, which followed the FEMA P-804 design solutions. Although many advances in building code resilience, adoption, and enforcement were made in Louisiana and nationally, between Hurricane Katrina and Hurricane Ida's landfall 16 years later, Hurricane Ida caused damage and catastrophic failures to residential buildings of all ages in August of 2021, even though it was not a design-level wind event. This demonstrated the need for wind retrofit projects to help minimize future damage of residential buildings in hurricane-prone regions. Therefore, it was decided that additional technical guidance through the update of FEMA P-804 was needed to facilitate the development of wind retrofit projects for residential buildings. The second edition of FEMA P-804 was published in April of 2023 and includes clarified and updated guidance based on post-damage assessments and lessons learned following the destruction of hurricanes left behind over the past 12 years of observations, as well as research in the ever-growing field of wind engineering. A significant change between the first and second editions of FEMA P-804 is that the second edition now references the Insurance Institute for Business and Home Safety, or IBHS, 2020 Fortified Home Program Standard, or simply Fortified Home, as a basis for each level of the mitigation packages. This new edition of FEMA P-804 also references the most up-to-date building codes and standards, including the 2024 I-codes, which are anticipated to be published in 2023, and recently released ASCE 7-22. It includes revised benefit cost analysis pre-calculated benefits for the updated FEMA mitigation packages and allows for the consideration of current economic conditions. Throughout the remainder of this presentation, we will be stepping through the updated content in FEMA P-804, particularly chapters 1 through 5. Thank you for your time and attention. FEMA is truly pleased to have updated FEMA P-804 to help fund future wind retrofit projects, which have been demonstrated to increase the natural hazard resiliency of the built environment, especially single-family homes.
Thanks, Donald. Hi, my name is Samantha Krautwurst, and I work as a contractor to FEMA. I'm going to be giving you an overview of a summary of chapters 1 through 3 of FEMA P-804 today. I'll then be joined by my colleague Eric Stafford, who will provide an overview of chapter 4. You'll then get to hear from me again about chapter 5. So let's get started with chapter 1. Chapter 1 provides an overview of FEMA P-804. It defines the purpose and basic scope of the publication and the need for the technical guidance, which Donald touched on briefly already. Another good visual example can be seen on this slide of a gable end failure that occurred following Hurricane Michael. Chapter 1 also discusses wind retrofit projects, including the eligibility and minimum requirements for FEMA P-804 mitigation packages. It concludes with a quick overview of the overall organization of the publication, which Donald previously covered. The purpose of FEMA P-804 is to provide guidance on how to improve the wind resistance of existing 1- and 2-family dwellings, excluding townhouses and manufactured housing units in hurricane-prone regions of the United States and its territories. However, although the guidance is primarily intended to be applied in hurricane-prone regions as defined by ASCE 722, may also be applied in non-coastal areas subject to high winds. We've already touched on how every year homes in the hurricane-prone region are subject to high winds that cause extensive damage and threaten the safety and security of residents. But did you know that much of this wind-related damage can be reduced or prevented by improving the performance of homes through retrofits? So how does FEMA P-804 help with this? FEMA P-804 summarizes the technical information needed for selecting and implementing cost-effective FEMA-funded wind retrofit projects for existing 1- and 2-family dwellings in hurricane-prone regions of the United States and its territories. FEMA's Hazard Mitigation Assistance Grant Program funds wind retrofit projects and requires those projects to meet the criteria in FEMA P-804. We will define and discuss what the hurricane-prone region is in the next chapter. Not only do residential wind retrofit projects reduce the vulnerability of and damage to houses from wind, but also from wind-driven rain. Wind-driven rain can occur during a long-duration high wind event such as a hurricane. In fact, FEMA has frequently documented this phenomenon during their mitigation assessment team field deployments after hurricanes. Even though there has been recent evidence that there is better structural performance for new construction built to more modern building codes, wind-driven rain has consistently caused extensive and costly water intrusion damage when it enters through wind damage envelope components. Damaged envelope components can include roof coverings, wall coverings, roof ventilation components, soffits, and windows and doors. FEMA P-804 mitigation packages provide techniques to mitigate against wind-driven rain while also strengthening the structural integrity of the house. FEMA P-804 groups sets of wind retrofits into mitigation packages. Each mitigation package consists of several wind retrofit mitigation measures intended to reduce future losses. Each mitigation package also corresponds closely to IBHS 2020 Fortified Home Standard Fortified Home Hurricane designations as seen in this figure. In fact, when utilizing FEMA P-804, you should also have a copy of IBHS 2020 Fortified Home Standard handy. However, in addition to the Fortified Home Hurricane designation requirements, there are FEMA grant requirements defined where more conservative criteria than the 2020 Fortified Home Standard must be implemented to receive FEMA funds for retrofit projects. All mitigation actions in a mitigation package must be implemented to qualify for funding. In addition to qualifying for FEMA funding, you may also be able to receive a fortified designation for your wind retrofit project that may qualify you for additional insurance benefits in qualifying states. Additional eligibility or administrative documentation may be required to do this. FEMA has basic, intermediate, and advanced packages. There are two different options for the basic package depending on if the roof covering replacement is completed or not. The evaluation process we will discuss in Chapter 3 will identify whether the roof covering needs to be replaced. FEMA mitigation packages should be implemented cumulatively, beginning with the basic mitigation package. That means that for a house to successfully meet the criteria of the advanced mitigation package, it must also meet the criteria of the basic and intermediate mitigation packages. As you've probably gathered, FEMA P-804 contains information and guidance for homeowners, contractors, evaluators, registered design professionals, also known as RDPs. Evaluators play a vital role when a wind retrofit project is considered, as can be seen on this slide. Evaluators must possess sufficient knowledge of the design and construction of residential buildings to perform these evaluations, but they need not be an RDP. However, the evaluator should have knowledge of and familiarity with the wind retrofit mitigation packages, their intent as described in this guide, and any limitations due to existing conditions. An RDP would be needed when the retrofit solution is outside of the prescriptive solutions provided within the guide. Eric will touch more on this later. One new part of Chapter 1 to note before we move on to discussing Chapter 2 is Table 1. Table 1 compares the eligibility and minimum requirements identified in Chapter 2 of 2020 Fortified Home Standard and the corresponding FEMA grant requirements. Some of the items compared are shown on the screen here and include applicable regions, qualifying dwelling types, ineligible and qualifying foundation types, reference codes and standards, and documentation requirements. During this portion of the training, we will go through Chapter 2 of FEMA P-804 titled Identifying the Risks and Desired Level of Protection. When looking to understand the wind-related risks to a house from hurricane, it's important to know how the wind risks are defined, the building code and local requirements to which the house was constructed, and the methods and materials used during construction. This chapter will focus on answering these questions while discussing wind hazards in coastal regions and how to identify wind risks for a particular site, how and when building codes and standards address these hazards, and the level of protection provided before and after implementing a wind mitigation project. So where do we mean when we say the hurricane-prone region? ASC 722 defines this as the U.S. Atlantic Ocean and Gulf of Mexico coast where the basic or the design wind speed for risk category 2 buildings, which include 1 and 2 family dwellings covered by the scope of this publication, is greater than 115 miles per hour. It also includes Hawaii and the U.S. island territories. The guidance in FEMA P-804 has been updated to reference the newest edition of ASC 7, the 2022 edition, also known as ASC 722. This edition is the reference standard of the 2024 International Residential Code. In addition to the visual of the hurricane-prone region on this slide, you'll see the inset shows the windborne debris region in purple checkered shading along a portion of the Gulf Coast. High winds can produce large amounts of debris that may become windborne and perforate the building envelope and openings, which allow rain into the building and cause interior water damage. This damage can be extensive and costly and even lead to mold and mildew growth. Furthermore, a window or door perforated by debris may also allow wind pressures to increase within the house, leading to structural damage. Recent FEMA mitigation assessment teams have concluded again and again that wind-driven rain resistance requires special attention in the hurricane-prone region. The mitigation packages in FEMA P-804 take this into account. While considering grant eligibility, there is no absolute geographical restrictions for where the mitigation packages in FEMA P-804 can be applied. This guidance in FEMA P-804, however, is geared towards houses in the hurricane-prone region. This is not to say some guidance is applicable to areas outside of the hurricane-prone region as well, but the guidance focuses on the unique hazards in the hurricane-prone region discussed on the previous slides. The first bullet on the slide corresponds to a user note in FEMA P-804 that all wind speeds in the publication correspond to ASC 722 3-second gusts basic wind speeds for risk category 2 buildings. 1 and 2 family dwellings are risk category 2 buildings. One easy-to-use tool for defining the basic wind speed for a location down to the address is the ASC 7 hazard tool. The tool can be accessed via the URL on this slide. Once you are there, you can enter a location and the tool will provide you with the basic wind speed for risk category 2 buildings from ASC 716 and ASC 722. In addition to defining the risk to a house when considering a wind retrofit project, the existing level of protection of the house should also be determined. Over the past few decades, building codes have progressed towards addressing design and construction practices that will result in buildings that are more resistant to high winds. However, much of the existing building stock in the hurricane-prone region was designed and constructed to codes and standards that required far less than current codes to mitigate wind damage, or were constructed to no code at all. It is important for the homeowners to be aware of the limits of the building code used to construct their house, the existing level of risk, and how and what extent the risk can be mitigated. Properly designing and constructing a building to a locally adopted building code provides a minimum level of protection for the wind hazard at a particular site for new construction. Homeowners can obtain information about both the effectiveness and limitations of the building code used to construct their house by using the resources listed here. So how do modern building codes take the risk from wind into account? Many states and communities now regulate the construction of buildings by adopting and enforcing building codes. Most locally adopted building codes in the United States are based on model building codes. The 2024 edition of the model building codes are what FEMA P-804 references. The approaches to wind design in these model codes are based on modern wind engineering provisions of ASC 7, as well as acceptable methods for enhancing wind hazard resistance. When considering residential construction and wind, the IRC also incorporates by reference other industry standards specifically recognized as accepted engineering practice for 1 and 2 family dwellings in high wind regions. Two examples are the American Wood Council's Wood Frame Construction Manual and ICC 600, Standard for Residential Construction in High Wind Regions. While compliance with codes and standards for new construction is not the topic or the subject of this guide, construction methods within these documents may serve as additional guidance for improving resistance to high winds. The level of protection provided by a house can also be increased through the use of best practices. Post-disaster investigations of areas impacted by hurricanes, including those conducted by FEMA MATs, have identified buildings that perform poorly did not have roof and wall coverings capable of resisting high winds or the intrusion of wind-driven rain using sealed roof decks or similar mitigation. Protection for openings, such as windows, doors, garage doors, soffits, and vents to resist high winds, wind-borne debris, and wind-driven rain. And this applies both to inside and outside of the wind-borne debris region. And a continuous load path for all loads, gravity, uplift, and lateral, to be passed from the building envelope to the ground through the foundation. The figure on the slide demonstrates this last point. In the photographs is a house with structural damage to the roof system from Hurricane Irma, where the estimated wind speed was 113 miles per hour. This is far less than the design wind speed of 180 miles per hour for the structure at that location. The close-up shows severed roof truss upper chords and blue circles and intact connections of lower top chords and top of wall in yellow rectangles. The insufficient load path or weak upper truss chords caused the failure. FEMA P-804 presents mitigation packages that, if implemented correctly, will reduce the risk of damage to a residential building from a long-duration, high-wind event by avoiding common failure modes, discussed on the previous slides, among others. However, there are several factors to consider in the decision-making process to implement wind retrofit measures, such as: is the risk level of the house high enough to make it a good candidate for a wind retrofit project? Which mitigation packages are cost-effective for the desired level of protection for the house? How much risk of wind-related damage is acceptable to the homeowner? These factors and others are discussed in further detail in Chapters 3, 4, and 5 of FEMA P-804, along with the consideration of cost-effectiveness of mitigation projects. For more information, using FEMA's Benefit Cost Analysis Toolkit, Appendix C of FEMA P-804 provides a step-by-step guide on using the toolkit with the mitigation packages presented in this guide, as well as guidance on pre-calculated benefits. To execute a successful retrofit on any house, an evaluation of its existing condition should be performed. This section of the presentation will provide an overview of how to do just that, while reviewing Chapter 3 of FEMA P-804 titled Evaluating Existing Houses. No two homes are exactly alike. During this section of the presentation, we will discuss how to evaluate a home, what to determine when evaluating a home, mitigation package evaluations, developing an evaluation report, and deciding what level of protection to achieve with a retrofit project. As we review this chapter, it should be noted that a qualified individual should evaluate the house and provide recommendations to the homeowner based on their findings. For the purposes of this guide, this person will be referred to as an evaluator. Acceptable evaluators may include building science professionals such as registered architects and engineers, building officials, and evaluators that are certified through state or locally recognized wind retrofit programs. IBHS's Fortified program requires evaluations of existing buildings to be performed by a certified Fortified evaluator. Therefore, homeowners who plan to seek FEMA funding for wind retrofits and wish to achieve 2020 Fortified Home Hurricane designation should use a certified Fortified evaluator to coordinate criteria across both programs. IBHS provides an online directory to help property owners find a certified Fortified evaluator on their webpage. The success of a wind retrofit project depends on thorough evaluations. The purpose of the evaluation is to determine whether the house is a good candidate for any of the wind retrofit mitigation packages. Regardless of which mitigation package is selected, the evaluation should cover the entire building envelope and conditions that would limit the effectiveness of the wind retrofit project. For example, if the wall covering is deteriorated, damaged, or not sufficiently fastened to the building, implementing a wind retrofit, such as replacing windows or strengthening the gable ends, will not provide the intended level of performance because other elements are likely to fail. This example highlights two of the main questions that need to be answered during the evaluation. Do any repairs need to be made before undertaking a retrofit project? And is the house a good candidate for retrofit? An evaluator should compile available documentation on the design and construction of the house, including upgrades. Any documentation on past evaluations, inspections, or installations should be compiled and noted. A physical walkthrough of the house should be conducted. Section 3.1, as well as Appendix B of FEMA P-804, provide additional guidance on evaluating buildings before starting a wind retrofit project, including what should be documented in the building evaluation. At the end of the collection of data and walkthrough, an evaluation report should be generated. The evaluation report should provide all reasoning and data used to support or not support the feasibility of the house for possible retrofit. More details on the evaluation report and what should be contained in it will be discussed at the end of this section. As described in the introduction to Chapter 4, each successive mitigation package must also meet the requirements of any lower-level mitigation package. The same can be said for the evaluation. Each evaluation should build upon any lower-level package evaluations. Section 3.1 provides a subsection for each mitigation package evaluation: basic, intermediate, and advanced. It is worth noting that when evaluating for the advanced mitigation package, which provides a strengthened continuous load path for the house, the level of invasiveness will depend upon the construction type and structural configuration of the house. The evaluation of the existing house will culminate in an evaluation report. This report should include significant findings, recommendations, and determinations to share and discuss with homeowners. The report should include a description of the existing condition of the building as described in this section and a recommendation for one or more of the mitigation packages. If repairs are needed before the wind retrofit project can proceed, the report should provide a general assessment of the work required. Some conditions, if found to exist in the home, can require extensive and invasive work and have very high associated costs. Appendix B contains further guidance on such situations. To facilitate the homeowner's decision on selecting which mitigation package is the best fit for their house, the evaluation report should describe the following findings: existing conditions needing repair, existing conditions that may prevent implementation of the prescriptive retrofit solutions, existing conditions that already meet the intent of the mitigation package requirements. Based on the three types of findings, the evaluation report should provide one or more of the following determinations. 1. The evaluated house does not qualify for all the prescriptive retrofits in this guide for the recommended mitigation package. 2. The evaluated house qualifies for all of the prescriptive retrofits in this guide needed for the recommended mitigation package. And/or 3. Existing conditions of the evaluated house already meet some of the prescriptive retrofits in this guide for any given mitigation package. Once an evaluation has been performed, the homeowner, in consultation with the evaluator, should make a final decision on which mitigation package to implement. Homeowners should select the appropriate mitigation package based on the level of risk that is acceptable to them and their families, and how much they are willing to spend to mitigate potential damage. When considering whether to undertake a retrofit project, homeowners should consider all the benefits and costs of the project. The benefits and costs associated with implementing a wind retrofit project should be effectively conveyed by the evaluator and well understood by the homeowner before a decision is made. Some costs and benefits are shown on this slide, including costs such as the total cost for the wind retrofit project, compliance with codes and local building departments, and effects of construction. Benefits shown include damage resistance, wind hazard insurance plans and premiums, federal assistance through HMA grant programs, and other state or local grant or loan programs that may be available. These lists of costs and benefits are not comprehensive. I'm now going to turn the presentation over to my colleague Eric Stafford of T. Eric Stafford & Associates to discuss all the mitigation packages in detail as he takes you through Chapter 4 of FEMA P-804, Technical Design and Construction Methods.
Thanks, Sam. Sam mentioned my name is Eric Stafford. I'm a building code consultant and consulting for FEMA on this particular project. This next segment, we're going to talk about the specific requirements within each mitigation package. We're going to break down each retrofit and discuss what specifically you have to do to meet any individual mitigation package. And we'll also discuss what the benefits are. Why are these recommendations here? Why is FEMA recommending them? And what are they going to help mitigate against? Okay, as Sam has already mentioned, there are three mitigation packages in P-804. There's the basic mitigation package, the intermediate mitigation package, and the advanced mitigation package. In this next segment, we're going to go through the specific retrofits within each mitigation package, and we'll also talk about what the benefits are to performing the retrofits within each mitigation package. Now, as we go through this, it may appear that the mitigation packages are arranged according to degree of difficulty. A better way of looking at it is they're arranged according to the degree of protection provided. One important thing to note about the mitigation packages is that they are cumulative, meaning, for example, to qualify for the intermediate package, you have to implement the basic package in addition to the requirements of the intermediate package. Similarly, for the advanced mitigation package, you have to implement the requirements of the basic mitigation package, the intermediate mitigation package, and the additional requirements of the advanced mitigation package. Now, it doesn't mean that these mitigation packages have to be performed in that order. In some cases, it may make sense to perform some of the items in some of the retrofits in the intermediate package before the basic mitigation package is performed. They don't have to be performed in that order, but the key point is that they do have to be performed and they are cumulative. Before we get into the details of each mitigation package, let's talk briefly about how P-804 corresponds to the fortified standard. The mitigation packages within P-804, they align closely with the designations within fortified. For example, the basic mitigation package aligns with the fortified roof designation. The intermediate mitigation package aligns with fortified silver designation, and the advanced mitigation package aligns with the fortified gold designation. In general, P-804 requires compliance with the retrofits in the fortified home standard. These are the basis of requirements. However, there are some retrofits where FEMA has additional requirements. These additional requirements are called FEMA grant requirements. And let's take a look at one of these FEMA grant requirements on the next slide. All right, so let's take a look at one of these FEMA grant requirements and how it works within P-804. For this example we have shown here, this is part of the basic mitigation package and dealing with the roof deck. Fortified states that when the roof covering, whether it be a shingle roof or tile or whatever the roof covering is, when it's being removed and being replaced, then you have to inspect the roof deck fastening more specifically. You have to evaluate the size of the fastener used to fasten the deck down and evaluate the spacing. And if it doesn't meet certain requirements, then the additional fasteners are required. And Fortified specifies a particular type of fastener that you have to use. Okay, so through the basis of requirements in FEMA P-804, we refer to section 4.3 of the Fortified Home Standard. But P-804 takes a step further and states that where the roof sheathing thickness exceeds 15/32 of an inch, a different fastener is required. And it's specifically called out here as an RS-03 ring shank nail, which is a little bit longer than the specified fastener in the Fortified Home Standard, and that's to account for the thicker sheathing that's required, so we get better embedment depth of the fastener within the roof deck framing. So that's an example of how what you'll see throughout P-804 with regard to these FEMA grant requirements. There's not a lot of them, but there are a few of them here and there, and we'll talk about them as we go through there. But they do go beyond what's in the Fortified standard. Okay, the topics we're going to discuss. We're going to look at the key requirements in each mitigation package. We're not going to go through every single detail about every mitigation package, but we are going to discuss the key ones. But all of them are not going to be covered in here. And one of the most important things that you can probably get from this presentation is that it's really important that you read all of what's in Chapter 4 of this guide and all of what's in the Fortified Home Standard. You can't use one without the other. Okay, they're intended to work together. There are key things from P-804 that are going to apply to the project. And there are key things from the Fortified Home Standard that are going to apply as well. And you need both of them. You can't have one without the other for a particular project complying with P-804. Okay, we'll talk a little bit about the limitations of prescriptive solutions. There are a number of prescriptive solutions within Fortified, and there are also a couple of other ones in the I codes that are referenced by P-804. What those limitations are. Okay, they're usually limited by wind speed, exposure category, but they also may be limited by building mean roof height and some other geometric factors as well. And then also there's minimum design requirements and testing requirements. So for example, if something has to be designed by a registered design professional, there's a minimum wind speed and minimum exposure category for a lot of the retrofits, not all of them, but for some of them. Same thing applies to testing. If a roof covering, for example, has to be tested, there's minimum requirements specified in Fortified and P-804 that product has to be tested to. For wind loads, P-804 references the 2022 edition of ASE 7. ASE 7 is our primary method for determining wind loads on buildings in the United States. Anytime in P-804 where it talks about wind speeds or wind loads or design pressures, they are to be determined based on ASE 722. Now, P-804 does allow the use of the 2024 wood frame construction manual for some wood frame retrofits. That edition of the wood frame construction manual is based on ASE 722. And there's also a couple of references to the 2024 IRC simplified component cladding loads method, which is also based on ASE 722. Now this part may get a little bit confusing, but within Fortified, the guidance and some of the prescriptive solutions, or not some of the, all the prescriptive solutions are provided based on ASE 710 and ASE 716. Okay, Fortified has not been updated yet to meet ASE 722. So within the context of P-804, when you use a prescriptive solution within Fortified, you have to meet the prescriptive solution specified for ASE 716. Okay, now it may seem like, well, you're using an older version of ASE 7, which is the case, but for the retrofit specified in P-804, the prescriptive solutions offered for ASE 716 either meet or exceed the wind loads that would be prescribed in that would apply in ASE 722. Okay, so for using the prescriptive solutions within Fortified, you have to use what's specified for ASE 716. All right, the retrofits in P-804 and Fortified are all based on a minimum wind speed of 130 miles per hour and exposure category C. For site conditions that exceed these limitations, that retrofit will have to be designed for those specific site conditions. 130 mile per hour basic wind speed and exposure category C is the minimum. Even if you're located in an area where the basic wind speed is, let's say, 110 miles per hour, the retrofit has to meet wind loads associated with a basic wind speed of 130 miles per hour and using exposure category C. Now we talked a little bit about the prescriptive solutions in Fortified. It's important to note though that those do have limitations. Many of the limitations are based on wind speed. So if your wind speed exceeds a certain threshold, you can't use those prescriptive provisions, or if it exceeds an exposure category or some other factor that's in Fortified. Fortunately, P-804 summarizes the limitations on all the prescriptive methods that are in Fortified in tables 2 and 3 in chapter 2. And it also identifies the minimum wind design requirements, as we talked about earlier, targeting a minimum wind speed of 130 miles per hour in exposure category C. That applies to most of the retrofits, but not all of them. Those are summarized in those tables in the front of P-804. To further help clarify, P-804 includes text boxes after each retrofit and identifies the prescriptive limitation and or the minimum design requirement if it applies. So for example, this one shown on this slide here, this particular prescriptive solution is limited to a basic wind speed of 130 miles per hour and exposure category C. So if site conditions exceed that, for this particular one, You can use prescriptive solutions provided there based on ASC 722, or the retrofit has to be designed in accordance with ASC 722. Let's talk a little bit about exposure categories, because you'll see exposure categories mentioned in P-804. You'll also see it mentioned in IBHS fortified standard. What exactly do these exposure categories mean? Exposure categories, from a wind design standpoint, are really a way to capture what the roughness of the Earth's surface is. The rougher the surface, the more it affects the flow of air as wind blows over the Earth's surface. The less rough, the less it affects the air, and all things being equal, the higher wind speeds will be a little bit higher for less rough surfaces than a similar type event for more rough surfaces. Okay, so we account for these differences in roughness by defining 3 exposure categories. There's exposure category B, exposure category C, and exposure category D. And we'll talk about exposure category D on the next slide. What we have in P-804 are general descriptions of exposure categories. You'll really need to go to ASC 7 to get the more specific details about how to determine what exposure category the site is in, and it can be a little bit complicated. But these general definitions we provide here are intended to just give you an idea of what of the types of exposure categories that would apply in the hurricane-prone region. Exposure B, which is the first one we have here. We have a picture kind of depicting a suburban area, which is a very typical exposure category B environment. You essentially, for most single-family homes, you're going to have about 1,500 feet of that type of exposure in all directions around the home to qualify for exposure category B. Exposure category C is a more open type exposure where you don't have a lot of trees. There are scattered obstructions. You're not in the suburban area. It's maybe an open field. So it's a less rough surface situation than exposure category B. Consequently, it's also the default exposure, meaning that if you don't meet exposure category B and you don't meet exposure category D, you automatically default to exposure category C. Exposure category D is the condition where a building is exposed to wind flowing over open water. It has to be a large body of water. It has to have a width of at least 5,000 feet, and that exposure D condition extends inland or downwind, if you will, for a distance of 600 feet or 20 times the height of the building. Now, for single-family dwellings, for houses, the 600-foot transition is what's going to control. So if you're located within 600 feet of a body of water that's at least 5,000 feet in width, then you're going to qualify for exposure category D. All right, so let's get into some of the nuts and bolts of the mitigation packages. We'll start with the basic mitigation package. As the title indicates, it is the most basic package of the packages in P-804. It focuses on securing the roof components, such as the roof covering, the roof decking, and underlayment, depending on which option you choose, and also improving the water intrusion resistance of the roof. The basic mitigation package generally does not require the use of a registered design professional, such as an engineer or architect, to complete. Now, there are 2 options. There's option 1, which applies where the existing roof covering is not being removed. There's a set of improvements that are recommended for option 1, and then option 2 would apply where the roof covering is being removed and replaced. Generally, option 2 is the preferred method for a couple of reasons. One is when you remove and replace the roof covering, you have access to inspect the roof deck, check the fastener size, fastener spacing, also look for any rot or deteriorated roof decking. And secondly, when you remove the old roof covering, you're going to put a new roof covering on, and it's going to be fastened and meet current building code requirements at the minimum level required by P-804 and fortified. All right, basic mitigation package option 1. Again, this one applies where the roof covering is not being removed and replaced. So if we got to strengthen and seal the roof deck and the roof covering is staying in place, we're going to have to strengthen and seal it from the underside of the deck instead of on the top, like we will with option 2, as we'll see in a few minutes. But we do this on the underside by applying a 2-part spray polyurethane foam adhesive in the attic to the underside of the roof deck. Okay, it's very important that that spray polyurethane foam adhesive be applied in essentially every nook and cranny in the attic. It needs to be applied at roof deck, at the joints between the roof sheathing panels, and all intersections between the roof deck and roof framing members. Okay. Now, this type of adhesive, there are specific performance requirements identified regarding core density and design uplift pressure that product has to be capable of resisting. But that foam adhesive is for basic mitigation option 1 is going to be used to seal and strengthen the roof deck. All right, the picture on this slide is representative of what using SPF adhesive in the attic and to the underside of the roof deck would look like. Okay, it's critically important that it be applied in all nooks and crannies, crevices and cracks, at every joint, every intersection of roof framing and roof decking. Because what this foam adhesive is going to do, it's going to enhance the connection between the roof deck and the framing members, and it's also going to seal those joints. And sealing those joints is what's going to help prevent water intrusion in the event that the primary roof covering is lost. All right, the final thing you have to do with option 1 relates to protecting ventilation components into the attic. Up until a few years ago, most attics had some type of ventilation, and many still do, although the unventilated or unvented attic option is becoming increasingly popular. So these ventilation components can allow wind and wind-driven rain to come into the attic area, so they have to be protected in some form or fashion. Ridge vents and off-ridge vents are required to be tested in accordance with a Florida standard. It's called TAS 100A. It comes from the high velocity hurricane zone in the Florida Building Code, which is Dade and Broward counties, or the old South Florida Building Code. But TAS 100A tests these attic ventilation components for wind-driven rain. So for basic option 1, ridge and off-ridge vents will have to be tested to TS 100A. Now for gable end vents, they're required to be protected with a removable shutter, okay, which will also protect from wind-driven rain entering the attic area. There is a prescriptive solution within Fortified for using wood structural panel to cover gable end vents. Option 2 of the basic mitigation package is a little bit more involved than option 1. In option 2, we're removing the existing roof covering, so we have access to the roof deck, and we can inspect the deck thickness and the fastening of the deck to the roof framing. Okay, for option 2, the roof deck has to be a minimum of 15/32 inch wood structural panel, which is plywood or OSB. That minimum thickness is predicated on a basic wind speed of 130 miles per hour and exposure category C. So for site conditions that exceed that, you'll need to use a registered design professional or one of the prescriptive standards, such as the Wood Frame Construction Manual, that are based on ASC 722 to determine the minimum roof deck thickness. You'll also want to inspect the roof deck for any damage or deterioration. Look for water damage. There are some prescriptive repair options within Fortified that may be used for certain conditions. One of the key elements of option 2 of the basic mitigation package is securing the roof deck. The roof deck will have to be secured by adding additional fasteners, or re-nailed as it's called. These additional fasteners are 2 3/8 inch long ring shank nails, and they are to be spaced at 4 inches on center throughout the entire roof. If the existing roof can be shown to meet these requirements, then this re-nailing is not required. Now, there is a FEMA grant requirement on this retrofit. Where the roof sheathing thickness exceeds 15/32 of an inch, FEMA P-804 requires the use of a 2.5 inch long ring shank nail. It's called the RSRS03 nail. But that only applies where the roof sheathing thickness exceeds 15/32 of an inch. Where it's 15/32 of an inch, it's not allowed to be less, but the 2 3/8 ring shank nail, as specified by Fortified, can be used. After securing the roof deck, the next retrofit is to seal the roof deck. When the primary roof covering is lost or damaged, the roof deck becomes particularly susceptible to water damage due to gaps between the decking. Employing a sealed roof deck will significantly reduce water intrusion through the roof deck when the primary roof covering is lost or damaged. In P-804 and Fortified, there are 3 options for installing a sealed roof deck for asphalt, shingle, and metal roof coverings. Sealed roof deck option 1 includes a combination of traditional roofing underlayment materials and a 4-inch wide strip of self-adhering tape covering all joints in the roof deck. This tape is required to comply with ASTM 1970 or AMA 711. The tape is required to be covered with felt underlayment, complying with ASTM 226 Type 2 or ASTM 4869 Type 3 or Type 4. This underlayment is required to be fastened at all laps at 6 inches on center, and in between laps at 12 inches on center in a 12-inch grid pattern. The fastener specified is a ring shank fastener using metal or plastic caps. Option 2 for sealing the roof deck for shingle and metal roof covers is very similar to historically how underlayment has been applied to low slope roofs. It essentially requires a double layer system of underlayment. Underlayment has to comply with ASTM D226 Type 2 or ASTM D4869 Type 3 or Type 4, and it's applied in a fashion where the entire roof is covered with a minimum of 2 layers of underlayment. The underlayment is fastened at the laps at 6 inches on center, and then in a 12-inch grid pattern between the laps. The type of fastener required is very similar to what we described for option 1. It's a ring shank roofing nail using metal or plastic caps. Option 3 for sealing the roof deck is really the most popular method that's used to seal the roof deck. It requires the use of a polymer modified bitumen product that complies with ASTM D 1970, and it adheres directly to the roof deck. Testing by IBHS has shown that this method is one of, if not the most effective method in reducing water intrusion through the roof when the primary roof covering is lost or damaged due to a windstorm. You will have to pay attention if the roof deck is OSB. Many OSB manufacturers apply a coating in the factory to their product, and this coating can inhibit the ability of the self-adhered product to stick to to bond to the deck. So in a lot of cases, you're going to have to apply a primer. You'll need to contact the OSB manufacturer, determine if a primer is required, and to determine what type of primer you will need. The last couple of slides we've talked about sealed roof deck options for shingle and metal roof coverings. For tile roofs, the options for sealing the roof deck are very similar. Option 1 includes a combination of taping the joints with a self-adhered product complying with ASTM D 1970 or AMA 711, and an anchor sheet, and then a self-adhered cap sheet. Option 2 involves the use of a self-adhered underlayment applied directly to the deck. There's a notable FEMA grant requirement that pertains to tile roofs, That is that for adhered concrete and clay roof tile, sealed roof deck option 2, the self-adhered underlayment direct to deck will have to be used. After the sealed roof deck is installed, a drip edge is required at all eaves and all rakes. The drip edge is required to be installed over the underlayment and fastened at 4 inches on center. The drip edge is also required to be sealed with a compatible sealant or compatible cement. For asphalt shingle roofs, a self-adhered starter strip is also permitted to be used. Next, a wind-resistant roof covering is required to be installed. Asphalt shingles are required to comply with ASTM D3161 Class F or ASTM D7158 Class H. All other roof coverings are required to have a design wind pressure rating that equals or exceeds the site conditions, but not less than the design pressures based on a basic wind speed of 130 miles per hour and an exposure category C. An important FEMA grant requirement to this section is that wind speeds have to be determined in accordance with ASE 722. The final retrofit for option 2 of the basic mitigation package is the same as the final retrofit for option 1 in the basic mitigation packages, in that the attic ventilation openings need to be protected. Ridge and ridge vents will have to be tested in accordance with TS 100A. We talked about that on a previous slide. And then also gable end vents need to be covered with a removable shutter. Now let's talk about the intermediate mitigation package. The intermediate mitigation package builds on the basic mitigation package. Whereas the basic package primarily covered retrofits for roofs, the intermediate mitigation package is a set of structural retrofits. This package includes protecting windows and doors from windborne debris, installing wind-resistant garage doors, protecting garage doors with glazing from windborne debris, strengthening gabled end walls, strengthening soffits, strengthening chimney attachments, and strengthening connections of attached structures. Let's talk a little bit about opening protection from windborne debris. FEMA P-804 and Fortified require all windows, skylights, entry doors, and garage doors with glazing to be protected from windborne debris. Now, this protection can be in the form of an impact-resistant product, such as an impact-resistant window or impact-resistant door, or it can be the form of an impact-resistant covering that protects a window or a door. The impact-resistant products or coverings, they have to be tested in accordance with ASTM E1886 and ASTM E1996, or the Florida Building Code Test Protocols TS 201 and TS 203. There's a key FEMA grant requirement related to opening protection. While Fortified permits the use of wood structural panels for protection of windows where the basic wind speed is less than 130 miles per hour, P-804 does not allow wood structural panels, which could be OSB or plywood, to be used as protection for any basic wind speed. For impact-resistant products and coverings, it's important that the product labels are maintained until the retrofits have been inspected. Some products have permanent labels and others have temporary labels that can be removed. It will be difficult to verify that the product is impact-resistant without a label. The image on the right of this slide is a typical impact-resistant window label. This is a temporary label and it can be removed. It tells us that the product was tested to ASTM E1886 and ASTM E1996 using Missile D. It also indicates other important information about the product, including its design wind pressure rating. The image on the left is a typical label for a hurricane shutter. It also indicates that this product was tested to ASTM E1886 and ASTM E1996. While the intermediate mitigation package requires garage doors with glazing to be protected from windborne debris, it also requires all garage doors with or without glazing to have a design wind pressure rating for the site condition, but not less than a basic wind speed of 130 miles per hour and exposure category C. Similar to windows and shutters, building codes require garage doors to have a label indicating certain performance requirements. A typical garage door label is shown on this slide. This label indicates that this garage door has a design wind pressure rating of positive 30 psf and negative 33 psf. It also indicates that this door is impact rated in accordance with ANSI DASMA 115, which is the impact standard for garage doors. Gable end wall retrofits are an important part of the intermediate mitigation package. Gable end walls are particularly vulnerable to out-of-plane wind loads because of the hinge created at the intersection of the triangular portion of the gable and the top of the wall below. Gable end wall bracing will typically need to be designed by a registered design professional. The bracing method chosen must be capable of resisting wind loads for the site conditions, but not less than a minimum basic wind speed of 130 miles per hour and exposure category C. Prescriptive solutions are permitted in accordance with Appendix C of the 2024 IEBC or Chapter 17 of the 7th edition 2020 Florida Building Code Existing Building. However, FEMA grant requirements apply an extensive set of limitations on using the prescriptive solutions. We'll discuss some of these limitations on the next few slides. If any of these limitations are exceeded, design of the bracing by a registered design professional is required. This slide provides an illustration of the typical methods used to brace gabled end walls. The left figure shows the use of a series of diagonal braces to brace the gabled end wall. This bracing scheme will have to be designed by a registered design professional. The figure on the right is a depiction of the prescriptive solution that uses a series of horizontal braces and studs to strengthen the gabled end wall. However, a registered design professional may also design a bracing scheme that uses horizontal braces similar to the prescriptive solution to strengthen the gabled end wall. As previously mentioned, there's an extensive set of limitations on using the prescriptive solution in the 2024 IEBC or the 7th edition 2020 Florida Building Code Existing Building that fall under FEMA grant requirements. General eligibility conditions are covered in Appendix C of the IEBC and Chapter 17 of the Florida Building Code Existing Building. If these eligibility conditions are not met, the prescriptive solutions cannot be used. Additional limits for FEMA grant requirements include the mean roof height cannot exceed 33 feet. The site condition is limited to exposure category B or C. The height of the wall beneath the gable cannot exceed 10 feet. And where a gypsum board ceiling diaphragm is used to brace the gable end wall, the minimum length of the gypsum board ceiling diaphragm is required to be in accordance with Table 4. And we'll take a look at Table 4 in a few minutes. Further limitations include fastening and blocking of the gypsum board ceiling is required to be verified or retrofitted to meet the minimum criteria specified in the 2024 International Residential Code for gypsum board diaphragm ceiling assemblies. The horizontal braces specified in the 2024 IEBC are required to be continuous along the required length of ceiling diaphragm as determined by Table 4 or be spliced together as permitted for interrupted horizontal braces along the required length of the ceiling diaphragm as determined by Table 4. Similarly, the lateral braces specified by the 7th edition 2020 Florida Building Code Existing Building are required to be continuous along the required length of the ceiling diaphragm as determined by Table 4 or be spliced together as permitted for interrupted lateral braces along the required length of the ceiling diaphragm as determined by Table 4. Now let's take a look at Table 4. Okay, coming back to Table 4, this table in FEMA P-804 further limits the use of the prescriptive solution in the IEBC and the Florida Building Code Existing Building by establishing a minimum ceiling diaphragm length when a gypsum board ceiling diaphragm is part of the bracing method for gable end walls. The minimum length, which will generally be parallel to the ridge as shown in the image on the left of this slide, is based on the wind speed, roof slope, and gable end wall width. For example, a building with a roof slope of 5 and 12, located where the basic wind speed is 150 miles per hour, and having a gabled end width of 24 feet, would require a minimum gypsum board ceiling diaphragm length of 24 feet. Again, if any of these limitations specified in the FEMA grant requirements or the eligibility conditions specified in the 2024 IEBC or the 7th edition 2020 Florida Building Code Existing Building are exceeded, the prescriptive solution is not permitted to be used, and gable end wall bracing will have to be designed by a registered design professional. All right, next let's talk about retrofitting soffits. The poor performance of soffits continues to be an issue in windstorms such as hurricanes. When soffit panels fail, wind and wind-driven rain can enter the attic area and cause significant interior water damage to a home. Recently, building code requirements have been strengthened to improve soffit performance. These building code changes generally align with the retrofit requirements in FEMA P-804. For the intermediate package, the condition of the existing soffit, if present, should be evaluated. If it's in good condition, the existing soffit can be used. If it can be determined that it is capable of resisting wind loads for the site, but not less than wind loads determined using a wind speed of 130 miles per hour and exposure category C. Admittingly, this will be difficult to determine for many soffits. If the soffit is constructed of wood structural panels, the panel thickness, nail size, and spacing can likely be determined and can be analyzed for wind load resistance. However, other soffit panel products such as vinyl, fiber cement board are typically not labeled. Without some type of label on the product, it will be difficult to determine the wind load resistance of a soffit panel product. While Fortified permits the existing soffit panel to be used if it is in good condition, a FEMA grant requirement in P-804 requires the soffit panel to be capable of resisting wind loads for the site, but not less than wind loads determined using a basic wind speed of 130 miles per hour and exposure category C, regardless of the condition of the existing soffit. Additionally, aluminum soffit panels are not permitted to be used within 3,000 feet of the coast due to the corrosive effects of salt-laden air. To reiterate, if the manufacturer of the soffit panel cannot be identified, so that you can verify that the panel meets the minimum design wind load specified in P-804, or if it's not in good condition, the soffit will have to be replaced. The new soffit panels must be capable of resisting a design wind pressure for the site, but not less than wind loads associated with a basic wind speed of 130 miles per hour and exposure category B. The design wind loads on soffits will have to be determined using ASC 722, or alternatively, the simplified method in Table 3 R301.2.1 paren 1 in the 2024 IRC could also be used. Soffit must be attached at both ends, meaning at the wall and at the fascia board. And if the soffit span exceeds 12 inches, intermediate supports are required so that no span of the soffit exceeds 12 inches. A few important notes about vinyl soffit panels. The use of vinyl soffit panels are common because they are inexpensive and relatively easy to install. However, there are a couple of key installation requirements I'd like to share with you. Vinyl soffit panels are required to be fastened at both ends of the soffit panel, meaning at the fascia board and at the wall to framing or some other wood support such as a ledger. It is common practice to only fasten the soffit at the fascia board and float the other end of the panel in a vinyl siding accessory channel. While this method is common because it's easy to install, it does not offer a good resistance to wind loads, as has been noted by numerous FEMA MAT reports. Another key issue for vinyl soffit panels is the span of the panel, the distance from the wall to the fascia board. If this distance exceeds 12 inches, intermediate supports are required to be provided so that the soffit panel span does not exceed 12 inches. For wood structural panel soffits, P-804 permits the use of a prescriptive solution in the 2024 IRC. This prescriptive solution specifies a minimum panel thickness, minimum nail size, and minimum nail spacing to achieve a specific design wind pressure. The required design wind pressure will have to be determined using ASC 722, or as mentioned previously, the simplified method in Table R301.2.1 paren 1 in the 2024 IRC. The final retrofits in the intermediate package we'll discuss in this presentation are strengthening of chimney attachments and strengthening connections of attached structures such as porches and carports. This retrofit applies to chimneys that are attached to the roof structure, not those that are supported on ground. Chimneys are required to be attached to resist the wind loads for the site, but not less than those determined using a wind speed of 130 miles per hour and exposure category C. As an alternate to designing the connections, a prescriptive attachment method is specified and fortified that can be used for chimneys that extend less than 5 feet above the roof deck and are not located within 4 feet of the roof edge. Connections of attached structures, such as carports and porches, must be capable of resisting design wind loads for the site conditions, but not less than those determined using a basic wind speed of 130 miles per hour and exposure category C. Similar to the chimney connection retrofit, an alternate prescriptive method in fortified can be used within the wind, geometric, and other limitations specified. All right, let's talk about the third and the most comprehensive mitigation package, which is the advanced mitigation package. This package builds on the intermediate mitigation package, and as we mentioned earlier, with the packages being cumulative, to qualify for the advanced mitigation package, you will have to complete the basic mitigation package, the intermediate mitigation package, and the additional requirements in the advanced mitigation package. The retrofits in this package, parts of them tend to be fairly invasive. Most of the time they're best done during a major renovation or storm repair. A couple items in the advanced mitigation package include wind pressure resistance for openings, exterior wall impact resistance, and developing a continuous load path throughout the structure. For the advanced mitigation package, all openings are required to have a design wind pressure rating for the site conditions, but not less than that for a minimum basic wind speed of 130 miles per hour and exposure category C. Windows, doors, and skylights are required to be tested in accordance with the AMA WDMA CSA 101 IS2 A440 standard, which is often referred to as the North American Fenestration Standard, or NAFS, or tested in accordance with the Florida Building Code Test Protocol TAS 202. These standards test these products for wind load resistance, water penetration resistance, and air infiltration, in addition to other operability tests. A key FEMA grant requirement is that all windows, doors, and skylights are required to have a PG rating in accordance with NAFS that corresponds to the required positive design wind pressure rating. The PG rating is usually limited by water penetration resistance of the products. By ensuring that the PG rating matches the positive design wind pressure rating, confirms that the product was tested for water penetration resistance at 15% of the positive design wind pressure rating, which is what is specifically required in TAS 202. Garage doors are required to be tested in accordance with DASMA 108, ASTM E330, or TAS 202. As we discussed for impact-resistant products and coverings, it is important that the product labels are maintained until the retrofits have been inspected. Some products have permanent labels and others have temporary labels that can be removed. It will be difficult to verify that the product has an appropriate design wind pressure rating without a label. The image on this slide is a typical window label. This is a temporary label and it can be removed. It tells us that the product was tested to what we refer to as the NAF standard and indicates that the design wind pressure rating is positive 70 psf and negative 70 psf. It also indicates that the PG rating of the product is PG 70. A key FEMA grant requirement is that the windows have a PG rating that equals the positive design wind pressure rating. Similar to windows and doors, garage doors need to be inspected to ensure that the label indicates a design wind pressure rating for the site, but not less than wind loads determined using a basic wind speed of 130 miles per hour. The advanced mitigation package also requires exterior walls to have a basic level of impact resistance. The minimum impact resistance must be equivalent to the impact resistance provided by a 7/16 inch wood structural panel sheathing. Exterior walls are not required to be tested for impact, but they are required to have a basic level of impact resistance. It's important to note that while fortified permits the use of 7/16 inch wood structural panels as opening protection where wind speeds are less than 130 miles per hour, P-804 does not permit the use of wood structural panels to protect openings from windborne debris. The final retrofit we'll discuss in the advanced package, and consequently the most difficult one, is providing a continuous load path from the roof to the foundation. This is the most invasive retrofit. Access is difficult without removing existing materials. It's typically best done during a major renovation or storm repair. It's required to be designed by a registered design professional. Appendix G and Fortified list the minimum elements that must be inspected and assessed by a registered design professional. Connections are required to resist wind loads for the site, but not less than a minimum basic wind speed of 130 miles per hour and exposure category C. FEMA P-499, the Home Builder's Guide to Coastal Construction, Technical Fact Sheet number 4.1, which covers load paths, and Technical Fact Sheet 4.3, which covers the use of connectors and brackets, both provide guidance on the concept of a continuous load path through the house. Connections are typically the critical components when developing a continuous load path. Additionally, FEMA P-55, the Coastal Construction Manual, provides more detailed guidance and examples of each link through the continuous load path. A solution should be followed that starts at the top of the house, at the roof sheathing, implementing an appropriate fastening schedule and attachment to the roof framing members, and continuing to the foundation. Okay, this concludes this segment. I will now turn the presentation back over to Sam to discuss implementing these mitigation projects.
Thanks, Eric. This final chapter of FEMA P-804, Implementing Mitigation Projects, offers guidance for implementing residential building wind retrofit projects and potential funding sources. And finally, before I wrap up, I will also provide you with a resource to ask any questions you may still have about FEMA P-804 and other FEMA building science resources. In addition to touching on several federal, state, and nonprofit retrofit programs that are currently available to homeowners and local governments, Chapter 5 also identifies factors to consider for wind retrofit projects, including building code compliance, local permitting and inspection requirements, and general construction challenges, as well as hazards other than high wind events. As we have discussed throughout this presentation, in order to qualify for FEMA funding, a wind retrofit project must meet the requirements of FEMA P-804. FEMA administers several programs that provide grant funding for both structural and non-structural retrofits to existing buildings for wind hazard mitigation. Wind retrofit projects are eligible through both the BRIC program and HMGP. While FEMA P-804 outlines minimum technical and performance-based grant requirements related to residential wind retrofits, refer to the latest edition of FEMA's Hazard Mitigation Assistance Program and Policy Guide, also known as the HMA Guide, for the most current FEMA policy on residential wind retrofit and HMA grant implementation requirements. As a reminder, Table 1 at the end of Chapter 1 summarizes eligibility requirements in order for a wind retrofit project to qualify for FEMA funding. We will touch on the last two sub-bullets on the following slides. This slide shows the key steps for wind retrofit applications and project implementation: mitigation planning, program funding, application development, project implementation, and project closeout. More details on each of these steps can be found in Section 5.1.1 of FEMA P-804. In order for a project to receive FEMA funding, the project must be shown to be cost-effective with a BCR or benefits cost ratio equal to or greater than 1. Appendix C of FEMA P-804 provides guidance on how to use the FEMA BCA Toolkit Hurricane Wind Module for determining cost-effectiveness of retrofit projects. As an alternative to performing a BCA within the FEMA BCA tool, version 6.0, pre-calculated benefits for the intermediate and advanced mitigation packages with and without roof replacement have been developed. A final thing to consider with FEMA funding are eligible and ineligible costs. Allowable mitigation costs for FEMA wind retrofit projects are for project components such as inspection and design and building codes, directly related and necessary for providing increased hazard protection from wind and wind-driven rain intrusion during a high wind event. FEMA will only compensate costs that are consistent with the requirements for the basic, intermediate, and advanced mitigation packages described in this guide. For the most up-to-date information on FEMA funding, refer to FEMA's Hazard Mitigation Assistance Program and Policy Guide, or HMA Guide. The HMA Guide contains the most current FEMA policy statement on residential wind retrofit and HMA grants implementation requirements. You can access it via the link on the slide. To help incentivize homeowners to implement wind retrofits, once the retrofits are complete and inspected, states and insurance companies have worked together to offer homeowners discounts on insurance premiums to reflect the improved building performance. Table 3 in Section 5.1.2 provides examples of state programs and organizations, two of which are shown on this slide, that educate homeowners, fund wind retrofit projects, provide tax benefits, and reduce insurance premiums for the residential buildings. As a reminder, should a property owner wish to use FEMA funding for a wind mitigation package in FEMA P-804, as well as take advantage of an insurance reduction in qualifying states for obtaining a 2020 Fortified Home Hurricane designation, additional fortified programmatic requirements may need to be met. For reference, Appendix A outlines 3 fortified levels of increasing protection to retrofit a house: roof, silver, and gold. Although Fortified Home Program does not provide grants, IBHS has developed the program in coordination with many prominent insurance companies that offer reduced home insurance premium in those states listed in Table 6 and potentially other states. Visit Fortified's program's webpage for more information and potential insurance reduction benefits. In addition to considering funding for and incentives from wind retrofit projects, the 3 factors on this slide need to be considered when implementing a wind retrofit project: building code compliance check, permitting and inspections, construction challenges. A building code compliance check may show additional work that needs to be done in order to implement a wind retrofit project. It should be verified that the project does not trigger provisions for existing buildings. Regarding permitting and inspections, homeowners should ensure that their retrofit projects are properly permitted and inspected as required by the local building department. Homeowners should be aware that most of the retrofit projects described in Chapter 4 of this guide would be considered repairs, alterations, or additions. More information on permitting and inspections can be found in Chapter 4 of FEMA P-762, Local Officials Guide for Coastal Constructions. Finally, the process for implementing a retrofit project should be carefully planned before removing the first piece of siding or pulling off the first shingle. Some examples of construction challenges that should be given consideration are shown on this slide and include matching retrofitted house exterior to the exterior of the house prior to the retrofit, selecting proper fasteners and connectors, and availability of materials. Lastly, homeowners should be aware that residual risks to their house always exist, even when properly implemented hazard resistance projects are completed. When applying for a FEMA grant, residual risk must be identified. While homeowners may retrofit their houses to mitigate wind hazards, residual risk will remain. No wind retrofit project completely protects a house against wind damage. Furthermore, the risks from other hazards described below will remain unless specifically addressed. The failure to properly identify and design to mitigate other hazards in coastal areas and hurricane-prone regions can lead to severe consequences such as building damage or even destruction. When following the guidance presented in this guide, homeowners should understand the elements of risk that remain to their houses. Publications such as FEMA P-55, FEMA P-762, FEMA P-499, and FEMA P-361 can help homeowners further understand the residual risks from wind retrofit projects and how to successfully account for and mitigate other relevant coastal hazards. The most significant natural hazard that affects coastlines of the United States and its territories includes tornadoes, coastal flooding, storm surge, erosion, and earthquakes. Thank you for your time and attention today. For any questions you have on the second edition of FEMA P-804, please feel free to contact the Building Science Helpline at 866-927-2104 or emailing FEMA-building-science-help@fema.dhs.gov. Questions on any of FEMA's building science guidance can be answered by the helpline. Thank you again.